So welcome back to our Chapter 9 review here. So we want to talk about scale factors, area factors, and volume factors, and how to use a scale factor to help me figure out between two similar shapes, what a new length, a new area, or a new volume might be. So to get us started, we're going to have the same setup for this whole page. So Tom has two similar boxes. The scale factor of the small box to the large box is 1 to 4. Write the scale factor as a fraction. So when we're given 1 to 4 as a ratio, another way that we've typically written ratios is we take the first number, write it on top, and then the second number, write it on the bottom. So our first number, the 1, becomes our numerator, the 4 becomes our denominator. And this now is a fraction which we can use in calculations. So we want to be able to switch from something like 1:4, which means a ratio of 1 to 4, to 1/4, which again means the same thing, but is mathematically a little bit easier to work with and manipulate. So let's get started on using that scale factor to actually answer some useful questions here. So if the length of the small box is 5 inches, find the length of the corresponding side in a large box. So I'm going to take my formula here. My length original is, boy, this is not working good. Length original, called length old, times scale factor equals length new. So let's zoom in here. No reason to be way out there. My writing will look so horrible this way either. Old, new. So my scale factor I know is 1/4, but I want to be careful here. Remember, when we're writing fractions and we're using them as conversion ratios, what I'm converting to goes on top, and what I'm converting from goes on the bottom. So if I want to convert to the small one, it makes sense to leave it as 1/4. But if I want to convert from the small one to the bottom, I want to switch from the small one to the large one, 4/1. My old length was 5 inches. The new length will be, 4/1 is 4, so 5 times 4 is 20, which is my new length. So the large box, and let's think about that for a moment. If the small box is 5 inches long, does it make sense that the large box, that's 4 times bigger, should be 20 inches? Yeah, that seems reasonable. It should definitely be bigger. If we forget this and we've got it flipped, that's okay, as long as we get to the end and we go, it's 1.25 inches long. Wait a minute. The large one shouldn't be smaller than my original, than my smaller one, so I did something wrong. Got to go back, flip that fraction. So next, we've got if the surface area of the top of the small box is 30 inches, calculate the surface area of the top of the large box. Well, let's pull out our formulas here. So if I look here, it's mostly the same formula, but that squared changes everything. So I'm going to take my scale factor here, and I'm still going. Let's do my old area. Let's zoom back in. Bear with me here. I'm trying to make it neat and give you some good space. So the area of my old box times my scale factor equals the area of my new larger box. So, scale factor squared. In fact, I'm going to put that in a different color. It's that important. We can't forget that. So if the area of my old box was 30, I'm going to take my scale factor, and again, I'm going from small to large. I've got to square that though. So I get 4 over 1, which is 4, squared is 16 times 30 equals my new area. So 30 times, it's 480, I bet. Hey, I can still do some mental math. Equals my area new. Now my units, it's worth pointing out, would be, it's still inches, but it's going to be inches square. So anytime I'm dealing with area, not only do I have to square my scale factor, but my units will also be squared. The reason why is that length deals with 1 dimension, while area deals in 2 dimensions. So volume here is going to be trickier yet. We're going to have left and right, up and down, and then we're going to even have in and out. So my volume formula here is going to be volume old. You know what? I'm going to do the same thing I did before. Put it over here. Volume old times my scale factor. And again, I want to remember that it's cubed. That is absolutely key. Can't forget that part. So let's look at the problem here. If the volume of the small box is 300, calculate the volume of the large box. So my scale factor is still the same. I'm going from small to large. So from small to large, but I need to cube that difference now. I'll give you my new volume. So 4 over 1 is 4. 4 cubed, it turns out, is 64 times 300. And that is going to be a decent sized number. So 64 times 300, 19,200. 19,200 equals my new volume. So if we look here, we went from a volume of 300 to a volume of 19,200. So it's a huge leap. Keep in mind that the scale factor has remained 1 to 4, but that difference of 1 to 4, that large box being 4 times larger, means that it's 4 times wider and 4 times longer and 4 times taller. So it's really 64 times bigger. It's quite a bit bigger. Even though the scale factor doesn't look like it should be that different, our volumes are going to be quite different. And to these two, these are my favorites. So buckle up. We're not introducing anything new necessarily, but we're going to use the equations that we have a little creatively. So if the ratio of the areas of the two similar rectangular prisms, my boxes, are 64 to 100, what's the ratio of their volumes? So remember, my area factor is equal to my scale factor squared. So let's take that area factor and let's work backwards to find my scale factor. So if my area factor is 64 over 100, I need to be able to think of some number that times itself equals 64 and some number that times itself equals 100. So I could think and I could say, okay, x squared equals 64. Take the square root of both sides, and I get x equals 8. Y squared equals 100. Take the square root of both sides. Y equals 10. So my scale factor is only 8 over 10. And if I think about that, if I square that, that's the same thing as saying 8 squared over 10 squared, which is 64 over 100. So that actually checks out. We did that right. So now, though, they didn't ask us for the scale factor. They asked us for the ratio of their volumes. What fiend wrote this question? Well, once I know that my scale factor is really just 8 over 10, the volume, finding their volumes, isn't too hard. I'm going to take my scale factor, 8 over 10, and now I'm just going to cube it. And again, what that really means is it's 8 over 10 times 8 over 10 times 8 over 10. That's the same thing as saying 8 times 8 times 8 over 10 times 10 times 10. And 8 times 8 times 8 is equal to 8 cubed over 10 cubed. Hey, that looks kind of familiar. And if I put that in there, 8 cubed is 512. And 10 cubed is going to be 1,000. So the ratio of their volumes, finally we've arrived at, is 512 over 1,000. These are tricky. So take some time, hit rewind, take a look at the example again. If you missed it, try the next one. Really all we're doing is we're working backwards from our area factor to our scale factor by taking the square root. And then from there, I'm getting my scale factor, which I can cube, both the top and the bottom, to get my volume factor, or the ratio of my volumes. All right. Last but certainly not least, if the ratio of the volumes of similar cylinders is 8 to 125, what is the ratio of their areas? So I want to take now not a square root, but a cube root, because I'm not squaring something like I did above, but I'm cubing it when I'm dealing with volume. So to do that, let's clear this. So I'm going to need this function, and it's going to give me the cursor up there. I want to put my 3 there to make it a cube, and then I'm going to tap underneath the radical sign, or that cube root sign, and now I'm going to put in 8. Hey, look at that. We got out of 2. Well, I can do the same thing, plug it back in there, and put in that 125, and let's, fingers crossed, we even get a nice friendly number again. So if we look, the cube root of 8 is going to be 2, and the cube root of 125 is going to be 5. Well, that's my scale factor then. If I want to find the ratio of their areas, well, I'm just going to take that scale factor and square it, which is going to be the same thing as my top squared over my bottom squared, which is going to be 4 over 25. So there we have it. So if there's any that you missed, go ahead, rewind, take a look at the video, then once you think you've got it, give it a shot on the other side. If you look at the video, you watched it still doesn't make sense, absolutely 100% come in and ask questions. Very happy to help with any questions you've got. But until then, we're going to call that the end of this video, and we'll see you again in the next one.